Okay. So we're going to take, find the volume of the solid generated by revolving the region bounded by y which equals x which equals y squared, y which equals 1, and the y-axis about the line x which equals -1. So if I was going to draw this thing, well, I am going to draw this thing. Okay, so that's the area that is going to get revolved. And it's going to be revolved around x which equals 1. Like so. Now, once again, when making a comparison between the disk and the shell method, okay? Remember, with the shell method, you're looking at where are the walls at. And so if I was going to consider a shell method for this problem, okay? Now, the walls of my shells that are being added together, where are they actually falling? They're falling below this axis, okay? And actually on this problem, you could do disk or shell. Either way, you're going to have to subtract something. Because if I did the shell method, what would I have to do? I would have to take a big cylinder with a hole in it, and then I would have to subtract this volume that is being created by the disk from that, okay? Now, let's look at it from the disk method, which is also going to require subtraction. Right? Now, this one is going to require subtraction because the volume that is being created by these disks, you look at the radius of the disks. And so since this radius of this disk, it does go into the area of the curve that we're looking at, but what's it going to do? It's going to create all of this middle space too. So what we're going to have to do is we can create this entire volume. And then what we're going to have to do is we're going to have to subtract out a cylinder from the center of it. So for this disk method, we're going to have to create a volume that is going to look like. And so it doesn't matter which one you pick. So this is what gets created with the disk method. And then we're going to have to subtract out this inner volume of this thing so that we end up getting like this. Or something like that. So it would be this type of shape with a hole in the middle. Okay, remember, since we're doing the disk method on this one, this is going to be an integration with respect to y because we're pushing up in the direction of y. Okay? So this distance right here is x. which equals y squared. And this distance right here is 1. So the radius of our disks are actually 1 plus y squared. Okay. So to do this, the volume would equal the integral from 0 to 1 of pi times 1 plus y squared, now squared, dy, minus the integral from 0 to 1 of pi times just 1 squared dy. Okay? So this volume right here is corresponding to this shape. And then this one is actually corresponding to this shape. And then their subtraction equals the volume that we're trying to create. Okay, so let's multiply some of this stuff out. You know what, I'm just going to start a new page. So this is going to equal the integral from 0 to 1 of pi. And this is going to be 1 plus 2y squared plus y to the 4th dy minus the integral from 0 to 1 of just pi dy. Okay. Now, instead of writing all this all over again, let's just say, all right, this pi times 1 and this pi times 1, they're going to cancel each other out. Okay, so we can just go ahead and get rid of those. And so this ends up just becoming the integral from 0 to 1 of pi times 2y squared plus now pi y to the 4th dy. Okay, and so that becomes pi times 2, now y cubed divided by 3 plus pi times y to the 5th divided by 5, evaluated at 0 and at 1. That becomes pi times 2 divided by 3, and then plus pi divided by 5. And that's it. You can leave the answer like that.